Assalamualaikum and a very good morning. I am Dr. Nur, my supervisor and also the panel for my final year project 1. My name is Nur Diyaanah Binti Hisham and I would like to present my final year project, which is investigation on wear and corrosion resistance of conifer coating prepared by electroplating. This presentation will be divided into 4 parts, which are project summary, background study, methodology and preliminary result. I would like to start with the project summary. In this study, cobalt nickel iron conifer coating has been applied to mild steel sample using electroplating method. Then, after the coating process, the sample will undergo wear and corrosion tests. The main objective of this study is to investigate the wear and corrosion behavior of conifer coating prepared by electroplating. For methodology, the main process are sample fabrication, oxide removal, coating process, wear test, and finally the corrosion test. The preliminary result from this study shows that the coated mild steel has lower wear rate compared to the uncoated mild steel. While for corrosion behavior, it can be deduced that the higher deposition time, the higher corrosion resistance of conifer coated sample. The major problems that are addressed in the study is several applications in industries such as oil and gas industries, automotive industry, chemical and manufacturing plants are exposed to wear and corrosion, which require large cost of maintenance. Besides, the problem that arises is there are many methods to prepare coating, such as hot dip galvanizing, thermal spraying, electroplating, and shredding. However, few methods require a lot of equipment and complex specification. The other problem is coating having poor surface properties. To overcome all of the stated problems, this study has been developed in order to achieve the following objective, which is to fabricate conifer coating that apply to the mild steel, to provide flexible method for coating, which is electroplating, and last but not least, to determine wear and corrosion resistance of conifer coating. Next, I am going to proceed with the background study. There are many previous studies related to this project. In this literature review, the previous study is divided into 4 parts according to the keywords related to this study, which are conifer, electroplating, pin-on-disc, and corrosion. From a study related to conifer coating, the result for wear test showed that conifer coated sample presents wear index of 0.003913 mm³ per Nm, which is less 13% by non-coated mild sample. While for corrosion behavior, the result shows that in alkaline environment, conifer nanoparticle produce smallest particle size, less oxygen content, and less corrosion rate. For electroplating, a study entitled Electrodeposition Principles, Application, and Methods shows the capability of electroplating in fabricating one-dimensional nanostructure, such as nanorods, nanowires, and nanotubes. For wear test, there are few methods that has been applied by few researchers, such as pin-on-disc, bolt-on-disc, and wear maps. A study which aims to develop wear maps for 115 REOL and ER wheel material has been conducted by Dario H. Mesaji using pin-on-disc tribometer. Another property that will be observed in this study is corrosion. From a study that has been conducted to study corrosion behavior of conifer coated onto the mild steel fasteners, there are 2 methods used to observe the corrosion, which are salt-fog test and pH test. A study of the uses of salt-fog test has been conducted by Muhammad Daud entitled 168 Hours Salt-fog Test, which aims to compare the corrosion resistance for mild steel coated with fast converter and mild steel coated with commercial primer. The scope of this study is focused on the wear and corrosion of mild steel sample coated with conifer coating. Number of samples that will be tested are 6 samples, where 3 samples will be tested according to ASTM G99 pin-on-disc test, and another 3 samples will be used for ASTM B117 salt spray test. This study will be conducted at various labs and workshops located at UiTM Shah Alam. In terms of limitation, the dot bone sample must have fixed thickness, which is around 2 mm until 3 mm only. Besides, there are other factors such as high cost of chemical powder has limited the electroplating process, and also lack of equipment has limited the method for sample fabrication. I am going to proceed with the methodology for this study. The figure shows in this slide is flowchart of the methodology in the study. The main process in the study is sample fabrication, oxide removal, coating process, weight test, and corrosion test. We will look at the first process, which is sample fabrication. The shape for the sample are dot bone for corrosion test and cylindrical shape for wear test. The sample dimension for droplet are 100 mm length, 60 mm width, and 2 mm thickness, while for the cylindrical sample, it has 10 mm diameter. Apparatus used are CATIA for sample drawing and water jet machine for sample cutting. Next process is oxide removal. Equipment used are sanding flap grit discs and grinder. The grit of flap discs used are 60, 80, 240, and 320. For this process, the grit of flap discs will be increased gradually and grinding must be performed at every part to ensure uniform removal of oxide layer. Then we proceed with coating process. Drenchment of electrode for electrode plating process are anode will connected to platinum while cathode connected to the milk steel sample. The composition of electrolyte bath are cobalt sulfate, nickel sulfate, iron sulfate, saccharine, boric acid, and ascorbic acid. The potassium hydroxide solution is used to increase the pH value of electrolyte bath. The parameters that keep constant throughout this process are current, which is 1.5 mA, pH value 4, and temperature from 50 degrees Celsius until 55 degrees Celsius. While the parameters that varies are deposition time, which are 15, 30, and 45 minutes. In this study, we are going to look at how this deposition time influences the wear and corrosion rate of the coated sample. The technique chosen for the wear test is spin on disc. The machine model used for this test is Magnum TE165 SPOD with ASTM G99 standard. This research was conducted to determine wear volume loss for pin and disc. The testing involved two different parts that were sliding over each other, a pin and a disc. The conical coated sample we decided to be fabricated into a pin with a cylindrical shape and slid against disc. Both specimens were tested using the same parameters, which is pin and diameter 10 mm, normal load 10 N, sliding speed 0.1 meter per second, disc speed 100 rpm, sliding distance 1000 meter, and wear strap diameter are 25 until 35 mm. For corrosion test, the sulfate test has been chosen to investigate the corrosion behavior of sample. The corrosion test will carry out according to ASTM B117 standard, which the parameter is ratio of sodium chloride solution 50 g of sodium chloride and NaCl plus 950 ml of distilled water. pH value is 6.5 until 7.2. The temperature is kept until 33 plus minus 3 degrees Celsius, and the duration of the sulfate test will be 24 hours. Last but not least, I'm going to present the preliminary result from this study. For wear test, the uncoated sample has higher wear rate compared to the coated sample, which are 0.003913 mm3 per Newton meter and 0.0004481 mm3 per Newton meter respectively. For the corrosion test, it can be deduced that the higher deposition time, the higher corrosion resistance of the coated sample. For sample which coated for 15 minutes, there are large light bound area of rust, while for 30 minutes, there are only several small light bound areas, and for 45 minutes, there are no obvious corrosion observed. I think that is all from me. Thank you.